When I first looked at the next generation science standards, I got excited. I saw words like electromagnetic radiation and wave properties, and I thought, oh wow, college level physics is coming to first grade. This is going to be awesome. And then I was discouraged because my lessons are only 10 minutes long, and how am I going to cover college level physics in 10 minutes? I can't. And then I read them closer and I thought, no, that's not what the objectives were saying. In fact, it was a little hard for me to tell exactly what the objectives meant, and if the lesson that I had planned on light was going to satisfy the guidelines or not. But I figured it out, and it turned out really cool. Before I show you, let me tell you quick what I do each week. Every week I have a Science Mom Day where I put on my lab coat, and as a volunteer I go to 3 elementary schools and I do science lessons. I keep my lessons to 10 minutes and I do them over and over and over again. I will repeat the same lesson between 12 and 14 times, depending on the week, to kindergarten to 5th grade students. And since I repeat the same lesson so many times, I learn a lot about what works well and what doesn't work, and I'm going to share with you today several tips for how to teach about light in a fun and engaging way. Tip number 1 is to make a color wheel. I colored mine with markers, but if you have access to a color printer or to true bright type of paper and want to make one with truer colors, it will work even better. Notice how my red is a little bit of a pinkish red. And so that means when I spin it, it didn't go completely white, but it went kind of to a light pink or a light green, depending on the viewer. So, piece of cardboard, paper, and then on the back I have 3 squares of cardboard that I duct taped together. And I fit these onto a hand drill. You could also use an electric drill or a egg beater. And then we would talk a little bit about how if you mix different colors of light, then you get white. And this was the first example of that. I would ask the kids, what color do you see when I'm spinning slowly? And they would say, I see all the colors, and then I would spin it fast. This demonstration won't work on film, so I'm not able to show you exactly how it looked, but it was something like this. And it was so much fun to see their reaction. Jaws dropping, eyes going wide, they were just amazed. And to most of the kids, when I spun this, it looked like it was a very, very light pink. It didn't go quite completely white because, again, these colors are not quite true red, green, orange, etc. But it went very, very light pink. To some kids it looked very, very light green. It was really a really great exercise and very, very simple and easy to do. And another fun thing that you can do along the same vein is make a Fenchner wheel. So this one, when you spin it, it's only black and white, but when spun fast, some people see colors. You have to see it in person because of the way the optical illusion works. But this one was a lot of fun too. Some of the kids would see light purple and greens, other people saw orange and reds, and when I spun it the other direction, they would see different colors. So another real fun and simple thing you can do to talk about light. My next tip is something really simple, but was a lot of fun, especially for the kindergartners to 2nd graders. I would say light is a wave. And in my mind, I'm cringing a little bit because I'm like, no, it's not. If there's the particle wave duality of light, and it's not really a wave, but that's kind of the concept that we're trying to get across, to think of light having wave properties. And so I would say, everybody say light is a wave, and all the kids would say light is a wave, and while we did that, we would move our hands like this. So say, light is a wave, and they would all do this, which was fun. And then I would say sometimes it has lots of energy, and I would do really exaggerated motions, and then I would say, and sometimes it has less energy, and we would do a nice calm wave. And this is useful because it's fun, and anytime kids are speaking and moving, they'll remember it better than if they're just listening, and it helps them to actually feel that ultraviolet light, when we moved like this, has more energy than red light, which moved like this. And it's a great way to just kind of introduce the electromagnetic spectrum, where you have different wavelengths of light have different levels of energy. The supplies for this activity are very simple. All you need is a clear glass, a flashlight, and then a little bit of milk. It's very easy to put too much milk in the water, so remember that less is more, and just use a teaspoon or so. And skim milk works better than whole milk. Now the camera didn't pick up the colors the same way that my eyes did, and so this looked different when I did it for the kids and at home than what you're seeing in the video.
And the whole idea here is that the light will look different depending on how much of the milky water it's shining through. So when you shine from the bottom, it looked a little bluish. When you shine from the side, it looks more yellow, maybe with a little bit of orange. And when you shine it from the top, it looks red. Again, this didn't show up very well on the video, but at home and in the classroom, the color changes were very impressive. This activity is a great way to explain sunsets and why the sky changes color in the evening. And it's because of how much atmosphere the light is passing through. The more atmosphere that the light has to pass through, the more dust particles that it's going to bump into, and that's why you see the change in color. A quick reminder, if you have too much milk in your glass, then you're just going to see white no matter what direction you shine the light.
And by far the coolest thing that I did on my light lesson day was to make white light from a rainbow. So I took 4 flashlights and I got a pack of colored balloons and I cut off the top of a yellow, blue, red, and green balloon. The yellow balloon was a little too bright if I just used 1 balloon, so I doubled it up. There are actually 2 balloons on this one, but the rest of them just have 1 balloon. And I put them into a box because I wasn't sure if I was going to be able to dim the lights. And so I made this little box out of duct tape, clear tape, and cardboard, and I've got a drawing of a rainbow on the back that is offset. If I were doing this again, I would actually make one of these instead, just a little thing that says light, where you just used cardboard to make those stick up, because if you have depth, so that then the shadows are still colorful, but then you see the image become white, it looks really, really cool. So if I were doing it again, I would do it this way, or you could also just cut out, kind of make a reverse image, cut out the word light, and then again, just use some cardboard squares and duct tape to make it so that there's separation there. That's how I would do it if I was doing it again. But let me show you what our light box looked like. It was really, really cool.
There are a lot of ways to make a rainbow. A garden hose plus sunlight was too messy to do indoors. Shining a flashlight on an underwater mirror was temperamental and didn't work very well. And because my flashlight was not very strong, I didn't have good luck with my prism. The rainbows that I made were very faint and difficult to see. Shining a flashlight onto the back of a CD, on the other hand, worked very well. We got excellent rainbows that were bright and easy to see with this method.
I hope those gave you some good ideas of activities that you can use to teach about light. And before I get into the science standards themselves, I want to point out that these next generation science standards are general guidelines. It's better to think of them as pointing you in a certain direction than a concrete lesson plan with, you need to do exactly A, B, C, D, E. There's a lot of latitude in how they can be interpreted, and I'm just giving you my interpretation. The first science standard to deal with light in first grade is PS4-2. And it states, make observations to construct an evidence-based account that objects can be seen only when illuminated. My plain speak translation of that is, hey, ever notice how you can see things when the lights are on, but you can't see things when it's dark? It's an important realization to have, and there are a lot of different ways that you could cover this in a class or at home. You could watch a video clip about caves, you could have maybe a treasure hunt with the room being dark and kids using flashlights. Making white light from colored lights, that we just did, I think fulfills this one really well. And then I also have a little activity of trying to move light without moving a flashlight that you could do that would satisfy that, in my opinion. The next one, PS4-3, says, plan and conduct an investigation to determine the effect of placing objects made with different materials in the path of a beam of light. My plain speak translation of that is, put different stuff in front of a light and see what happens. And here's how I would do it. I would take a light and I would shine it down at the floor in a room that was dim, and then I would challenge the kids to say who can move the light without moving the flashlight. We would try blowing on it or like waving our hands through it to see if we could get the light to move, and of course it wouldn't. And then I would have a little box with different squares of material, so saran wrap, waxed paper, regular paper, cardboard, and I would save the reflective ones, the tinfoil and the mirror, for last. And we would try all those different materials and see how the light responded to those things being placed in front of it, and if we could get it to actually move and illuminate something other than the floor by putting those materials in front of it. And then when we take out the mirror, that's kind of the grand finale. If you put the mirror underneath, then you can bounce the light all around the room depending on how you angle it, and that's a lot of fun. So there's a lesson I did for PS4-3. And last but not least, we have PS4-4, which says, use tools and materials to design and build a device that uses light or sound to solve the problem of communicating over a distance. And my plain speak translation of that is, try to talk to someone who's far away. How can you do it? There are a variety of ways that you can approach this in the classroom or at home, but my personal favorite is to teach kids how to send the SOS signal with sound and light. I made a little worksheet that goes along with that, where it talks a little bit about Morse code, and then the kids have this fun little unfortunately, fortunately scenario, and they get to rescue 2 cartoon characters who are stranded in a floating umbrella. So if you'd like to pick up this one, or other worksheets, or the color wheel or Fenchner wheel, all the things that you saw in these videos, I've got those available at patreon.com and teacherspayteachers.com. There are links in the description if you want to get those. So I hope this has been useful to you. Thank you for watching, and if you have requests for other next generation science standards that you would like to see me translate and give lesson ideas for, just let me know. Thanks again for watching, and I'll see you next time.